The next thing we should talk about is spatial projections and coordinate systems. So the very first spatial projection I want to talk about is the geographic one, and the reason mainly is because everything is basically derived from this particular spatial projection. So what is a geographic coordinate system? This coordinate system will use three-dimensional spherical surface to define locations on Earth. So we take our typical coordinate system, our x, y, z axes, and we basically put it in the center of the sphere, or most likely the center of mass of the sphere. A geographic coordinate system will include an angular unit of measure, a prime meridian, and a datum based on a spheroid. So a point will be referenced by a longitude and latitude value, so some point on the surface of this sphere, and usually we go from the center of mass, and there is a radius there, and we call that sometimes rho. And then from there we kind of determine exactly where that is located from the origin. So longitude and latitude. So longitude and latitude are angles measured from the Earth's center to a point on the center's Earth. So that's what we're going to use to kind of lock in exactly where that point is located. So again, the center of the Earth is basically 0, 0, 0, which is the origin. And then we take a look at this angle here, which we call phi, which is our longitude value. And then we take a look at our latitude value, which we sometimes call theta, to locate where that point is on the surface. So an example system is the NAD 1983. And this basically stands for the North American Datum of 1983. It's based on both Earth and satellite observations using the GIS 1980 spheroid. The origin for this datum is the Earth's center of mass. The next spatial projection I want to talk about is one called projected coordinate system. So what is a projected coordinate system? This coordinate system is defined on a flat two-dimensional surface. So the one we just looked at before was kind of a sphere, and this one is flat. So as mentioned earlier, everything is kind of based off the sphere. So if we just examine this graphic, we can see here that it starts with the sphere here around the center, and then there's a little light bulb in the center that shines in the sphere, and you can see that the lines on the sphere shines out on this little cylinder shape here, and then the cylinder shape is pretty much just rolled out flat like this. So that's how that works. Unlike a geographic coordinate system, a projected coordinate system has constant lengths, angles, and areas across the two dimensions. So again, taking a look at our cylinder, again our origin is going to be in the middle. Some point, which is referenced on the surface of the cylinder, can be located using this particular coordinate system. So basically we draw a line out from the z-axis, which essentially becomes our radius, and then we kind of draw that line again, or that radius, down at the base of our cylinder, and then reference it from the x and y axes. And then from there we draw an angle from the x-axis to where that radius is located at, and we call that theta, which is our angle. And then we need to determine how high it is from this base, which is basically our height, or sometimes we call that z, which is the height of our cylinder, or the height from the origin to where that radius is located at. And this is how we can locate points on the surface of a cylinder. A projected coordinate system is always based on a geographic coordinate system that is based on a sphere or spheroid. So the next thing we should probably think about is meters or feet. So data can come in meters or feet. If the option exists, when you go out to download GIS data, you're probably going to want to choose your units so that you don't have to spend a lot of time going through and reprojecting things. Sometimes you may not have that choice. Everything may just simply come in meters. That happens to be the default of most GIS data is often in meters, so you'll have to reproject your data in GIS. When performing analysis, all data must be in the same spatial projection.